So good morning, everybody, and welcome. It's a real joy to have you on the webinar today, and we welcome you to the Crack the Code to Ultimate Development Productivity. I'm always amazed because of technology that we have such a fine representation from around the world, and today, no different. We have 6 countries represented on our call today, so it's amazing to have you on the call. Thank you so very, very much for your time. My name is Michael Buckton. I'm the sales manager for Amazic in EMEA and suitably supported today by one of our choice vendors, GitLab, and of course, a fabulous partner in Sue. We are a trusted distributor and partner to many companies around the world, and we provide software distribution and services which arguably empowers diverse industries around the world to thrive in a very competitive landscape. Sue, a highly certified partner of ours, who as a raison d'etre provides wonderful operational and development support to developers, is going today, together with GitLab, provide a cutting-edge CD solution, Multistax. And I think the context and the takeaway for everybody will be for us to realize what that integration of Multistax with our existing GitLab CI really means. And of course, the availability of AI to top it all. Just a few announcements before I hand over to Swami. We will be recording this and providing it later. There will be an opportunity to ask questions, which you can put in the chat piece, which we will deal with at the end of each presentation. And then there's an invitation by Sue to help you optimize your development pipeline and, of course, your DevSecOps practice in total. So that free consultation will be offered, and more will be said about that later. So I'm going to take this opportunity of once again thanking you for your time, for being here with us today. It's an absolute joy. And I'm going to now hand over to Swami. Thank you very much.
Thank you, Michael. Thank you for everybody on the call today. So I am going to share the agenda. So is everybody able to see the screen? Okay. Okay. So what I really want to cover today is just give you an overview of GitLab as a product. And then I want to follow that up with what I really feel are two approaches to DevSecOps in the market today. One is what we call a platform-led approach, which is where GitLab sort of really fits in. And then you have a point solution-led approach, which is also another way of DevOps being consumed in a lot of environments today. More specifically, this would be around Microsoft and a whole bunch of other point solutions around that ecosystem, right? And then I want to follow that up with GitLab's AI roadmap and what we're bringing in as part of that into our platform. And then a little bit of competitive analysis on maybe say Jira versus GitLab, maybe Azure DevOps versus GitLab. And so that is just to sort of bring out the comparative nature of the product in itself. And then I'm going to follow that up with a demo. As part of the demo, my partner, my technology partner, Bas, I think he's going to do a part of the demo, and then I'm going to follow it up with another section of the demo, which would be around GitLab as well, right? So if we're clear with that, I'm going to start off with the session today. So when we did a survey in the market, this is a 2023 DevSecOps report, 66% of organizations said that they would like to consolidate their tool chains, right? So anywhere between 84% to 90% of the organizations are using between 2 to 10 DevOps tools in their SDLC environment today, right? And about close to 70% of these developers are spending about a quarter of their time maintaining and integrating these tool chains, right? So now this in itself defines the problem statement, right? When you have too many tools in your SDLC environment, it becomes very difficult to manage them, not just from just a CapEx perspective, but also from an OpEx perspective, where you have to manage the patching, you have to maintain them, you have to do the updates, you have to, and all of these tend to be very cumbersome as an organization grows, right? So that's where this is the foundation of why GitLab was actually built. GitLab was built to sort of really consolidate the tool chain in the SDLC environment and drive that efficiency within the SDLC. Okay, so the tool chain sprawl sort of really undermines the transformation within an organization itself for a lot of the reasons I just mentioned before, right? So what we did as part of the product is we brought in 4 major personas, right? We brought in the project management teams, which are the business teams. Then we brought in the developers, and then we have the security operators, and then the platform operators. We brought all of these 4 personas into a single unified interface. And once we brought all these personas into a single unified interface, what that allowed us to do was we ended up creating this unified data model where there is a context of information that moves from one stage to another, right? If you really understand how sort of software is released to the outside world, you would realize that all these 4 personas, the code sort of really moves through from one stage to another, and the entire development cycle sort of passes through all of these 4 personas, right? So what we really provide, GitLab provides as part of the product, is an opinionated workflow, right? The product itself enables that opinionated workflow where all of these personas can come onto this platform and they can collaborate, and then they could get their work done. A project management, somebody who's responsible for maybe say, an agile planning or in their environment, they can utilize their GitLab plan function, which a developer can then pick it up, and then it can go through the rest of the SDLC loop, right? In terms of the competitive landscape, we pretty much compete across the entire stack of solutions across the various phases that I just described before, right? In terms of source code management, our obvious competitor is GitHub, right? Bitbucket in terms of, that's Atlassian. From a CI/CD perspective, we have Jenkins, we have Azure DevOps. From a repository management, we have JFrog. So from a CD perspective, we are competing with some open source solutions as well, like something like Argo CD, right? And one very important thing to understand is the concept of open core, right? A lot of customers ask me that, what is the difference between open source and open core? We are fundamentally, GitLab is an open source product. There is a community edition available. But what happens when the product moves from open source to open core is that we end up creating some additional features on top of that, then which we sell it back into the market as a paid offering. But fundamentally, the core of the product is open source. So that's essentially the difference between open core and open source. If anybody asks you, GitLab, people ask me, what is it open source? Yes, it is open source, but it is open core because we are providing enterprise-grade features on top of the community edition that is already available. Okay. If we've understood that so far, I'm going to go ahead with a sample workflow of what it looks like from a point solution perspective first, and then how does this differ from a GitLab perspective, right? So typically, if you look at any environment today, there is usually it starts with project planning, right? A project planner would maybe create an issue. That issue gets picked up by a developer. The developer starts writing the code in his IDE local environment, and then he pushes that into a source code management, something like Bitbucket. Now, once that is done, the code is pushed. The code then moves on to the build stage, which is where something like Jenkins comes in. It goes through the build process, and some sort of an artifact is created. It could be a container image. It could be some sort of a Java image. It could be anything, right? So it goes through that entire process. And then once the build process is complete, it moves into the security domain, right? Where your security operator comes in, the static scans, SAST and DAST scans sort of really start kicking in, right? But one very important point to note is in all of these different tools, right? Jira is a different tool. Bitbucket is a different tool. Jenkins is a different tool. Each of these are parallel flows. These are different workflows. These workflows are not inherently tied together. So every time something gets broken between any of this flow, it's usually not picked up or it's not sort of accounted for. There is no context that is moving from one stage to another, right? The problem statement that I was describing earlier. So say, for example, if a vulnerability is detected. Now, usually what happens is it's usually maintained as part of an Excel sheet, and then that is passed back into the development to either manually, and there is no compliance or governance. There is no sort of controls in place. Inherently, there are no controls in place from a software perspective that enforces that governance for a developer to go and fix that issue. If the developer fixes that issue, great. If it doesn't fix that issue, what is most likely going to happen is that identified vulnerability is going to move into production, right? And this is a very big problem, right? And the one that you see the icons highlighted in red is the context switch time that usually happens between code moving from one stage to another. This is, again, by no way an accurate, it's just a reference. It might vary based on the development environment with each customer, but roughly we can say that there is a significant amount of context that gets added between each stage. Okay. So once this is done, right, I mean, if you look at just the total context switch time that happens for this particular example, you'll say that's about 34 minutes and just for about 5 dev iterations. Now, for a small number of iterations, this might not look like a lot of time, but if you add up, thousands of iterations which are happening over months and years, this is actually a significant amount of developer productivity time that is wasted because of this complexity, right? And not mentioned in this slide is the challenge of actually maintaining these different tools in silos, patching them, upgrading them, and then making sure that the integrations are working as they expect. Right? With GitLab, that changes because we've natively integrated all of those 4 personas onto a single UI, and all the capabilities and the features that are needed from a platform operator perspective that are natively available within the platform. Of importance to note is the fact that we've integrated the security scanning capabilities within the platform, and it is now sits very close to the development environment. It is as close to, so every time a developer comes in, he creates a new feature branch, he can exactly see what he's writing, what he's building, what kind of vulnerabilities he's introducing as part of his build environment before he pushes his code to the parent branch. So what you end up inherently doing is when the code is committed, it moves to the staging environment or the production environment, the quality of code that is coming out of that development loop is actually very high quality, right? And I want to also point out in another slide, which I'll come to, why this is probably a better way of doing things rather than fixing the code once it has actually reached the staging environment or the production environment. Okay. So this is one of the fundamental reasons why GitLab sort of really exists in the market today. It's that entire concept of shifting security left. When I say left, you are bringing that security aspect closer to your IDE and closer to that development environment. Okay. So why is it a better way of doing it? Because when you identify bugs, when you identify vulnerability early in the development cycle, the cost of remediating that is quite low. So the more the more complex the code gets, the more the code gets integrated into the larger application code, becomes quite complex to troubleshoot. It becomes quite complex to remediate it as well. So as the stage keeps moving to the right, as towards the production environment, the cost significantly, the per hour cost per developer actually goes up quite a bit, right? So this is the data supports it, and this is one of the reasons why GitLab is so loved by a lot of IT development teams, and they are bringing this into their environment, this kind of an approach into their environment, right? So the takeaway really here is there are 2 kinds of approaches to DevSecOps in the market. One is a point solution-led approach, which is sort of you bring in your own tools, stitch them all together, and that it's debatable whether that will work for every environment, but the cost of managing, maintaining them tends to be very expensive. And the other one is an integrated approach where all the core capabilities of DevSecOps are available through a single platform for any external capability or any specialized capability that you need in terms of security testing. If the platform is not able to meet, you can always go ahead and integrate that. So what you end up eventually doing is the number of tools that you end up managing in your environment are significantly less, right? So I feel this is a much better approach, but if people disagree, they can always call it out, right? So from a customer standpoint, what is the goal, right? The goal is for any SDLC environments to make the developer more productive. You want to simplify the tool chain complexity for obvious reasons, for the ones that I mentioned before. You want to make sure the code that is coming out of your development environment is secure, and then there are as little vulnerabilities as possible. And lastly, to enable much higher efficiency and to automate things, you want to transform your development environment with AI, right? Now, AI is a very big topic, right? Everybody is adopting AI. And for a lot of software organizations today, AI is now a must-have to stay competitive, right? This was last year's information, right? But today, this number is slightly higher than what it was also last year. But the problem in the market today is most of the AI adoption today is only focused on coding, right? Now, this is a problem. So imagine your development teams are producing, with leveraging AI, they're producing a lot more code. But if that AI adoption has not penetrated the rest of the features in your SDLC environment, you are going to produce a lot more code, but you're going to overwhelm probably a couple of your other teams, right? Your security teams don't have that automation. So they are looking at a lot more vulnerabilities than they were looking at before AI, right? And that brings us to a problem statement. How do we actually look at adopting AI in the SDLC? So the way we do it with GitLab is we apply AI to each and every persona, right? So you have a whole bunch of AI features that are available for maybe, say, the project planning teams, whole bunch of AI capability features that are available at the development stage, at the security stage, at the operation stage, right? So we are applying AI throughout that SDLC. And the biggest differentiator from a GitLab perspective is because we end up creating that unified data model that I was talking about earlier. The ability for the AI to take context and give very efficient workflows becomes very, very easy. Imagine you are tying together 10 different tools, and all these 10 different tools have their own different AI solution, right? AI integration. Now you're going to be able to, the challenge becomes, how do we tie different AI-enabled softwares together? It becomes a very, very, very complicated process, right? And most of the times, if anybody who's used ChatGPT or any AI tool in the market, you would know that, prompt-based AIs, they are not consistent with the kind of output they provide, right? So, you're not going to be very efficient with your AI adoption strategy within the SDLC. Again, this is a very, very big benefit that we inherently have because of the context information that the data model possesses from one stage to another. Okay, so unlike some of the other point solutions in the market, we have the capability to bring in the right AI model for the right persona and the right use case. What that really means is that we are not commercially tied to any AI provider. We are not tied to OpenAI. We are not tied to Vertex. We are not tied to Anthropic. So depending on what is the right AI model for the right persona and the right use case, GitLab has the ability to bring in that model. And what I really call this approach is, this is a term that I coined, is open source AI, right? Because there is no commercial agreement with any AI provider that we have to use, unlike Microsoft, for example, that we will have to use OpenAI for pretty much everything. With GitLab, usually the customer has the flexibility to choose which AI model he wants to use. In fact, he can bring in an LLM model within his environment in a self-managed environment, and he can do a lot of those AI-enabled features, right? And today, as part of our GitLab Duo offering, we use Anthropic Claude for a couple of features. We use, Vertex, Google's Vertex for a couple of features. And I'm not sure about the remaining LLM models, but there are a few more. We can actually go back and look at the documentation if we have to. Right. Again, the unified data store architecture that I was talking about, that makes things very, very easy to implement AI. And most importantly, right, we do not use any customer or proprietary code for training these models. There is publicly available documentation that actually describes in detail on how we use AI and how GitLab Duo actually uses customer information. And the customer information is completely isolated from the features that we provide as part of our AI. So at best, what AI does today as part of Duo is automation. Okay. Because of the approach that GitLab has taken in the market, Gartner has rated us at the top of the Magic Quadrant. We were the leader last year. We were the leader this year as well. I don't have the latest slide, but I saw the report. We are also the leader for this particular year in the Magic Quadrant for DevSecOps platforms. In terms of where the roadmap is headed for GitLab AI, right? What we are trying to do is, today we have 4 personas, which I spoke about earlier, right? We have project planning teams, we have development teams, we have security teams, and we have the platform operator. But now moving forward, what GitLab is aiming to target is also data science teams, because they are also, once you have a secure DevSecOps platform, then because they are also an extension of the development environment, they have very similar requirements like code registry. You have model registries that are needed as part of data science and AI projects. So those capabilities are also being integrated within the platform, right? It is the same problem statement that existed in the DevSecOps world, where there were multiple tools, multiple environments, right? And the idea is to make sure that you want to consolidate as much as you can, right? So what we call this, we've coined the term, is model ops, right? Once you have DevSecOps in place, then a secure DevSecOps practice in place, then incorporating AI into your existing application becomes a lot more easier, because then you are able to integrate the MLOps development environment with your DevSecOps environment. So as part of this initiative and the direction the product has taken, we are now offering GPU-specific runners, which are specifically targeted for AI ML workloads. Okay. This is available both for self-hosted and SaaS. And also we have support for Python Notebook as part of our web IDE, right? So a lot of the tools, a lot of the code base that the data science teams are using can also be incorporated within the same DevSecOps platform. And lastly, from a Duo perspective, right? Today, if you look at our platform, most of our AI features are prompt-based, which means you will have to feed some input into it and to get some output out of it, right? Maybe some text summarization capabilities are there. But moving forward, where the product direction is headed is into an autonomous AI model, where an agent-based AI model, where the AI agent is going to run on the background, and it is going to be automatically be able to tie context between those different personas, right? So what's going to happen, in my view, is the context that the context switch that happens even within the platform of changing screens from one screen to another, that is significantly going to reduce. And on a single pane of glass, you're going to have the developer is going to have a lot of visibility of how his code is going to get impacted across the larger application environment. I'm very excited to see how this sort of really pans out. But for people interested, you can just go and search GitLab Duo workflow on YouTube. That sort of is a 2-minute, 3-minute video, which sort of walks you. It's a marketing video, but it shows through what the product is going to look like with the workflow feature coming out later next year. Right. So I want to lastly enter the final part of the at least the presentation. I'm going to follow it up with a demo once Bas has a chance to present his content. But the top reason that enterprises choose is they want to reduce that tool chain sprawl that I spoke about earlier. That's the number one reason. So as you reduce your tool chain sprawl, you end up saving costs on your CapEx. You make your operational environment a lot more easier. There's a lot more time that is available for the developer to focus on actual development rather than maintaining and managing a very large stack of tools, right? Security is another one, very big one. It's actually at the core of the product is you want to make sure that the code that is coming out of the developer inherently is of a very high quality and there are less vulnerabilities, as little as vulnerabilities possible when it's actually reaching production environment or it's reaching your security teams. So once it reaches your security operator, the burden on your security team sort of significantly reduces because from the starting point itself, security is being taken care of and the developer is producing a very high quality code. The other is very important for the executive is the visibility, the efficiency, being able to measure the efficiency of your SDLC environment, right? Because we have a unified data store and because we also have the context of what is happening in each stage, we are able to measure what is happening at each stage. And this measurement is done based on something called DORA metrics, which is an industry-defined term. And there are about 4 metrics that are out there, which I can't remember. But it allows the executive to sort of really understand what is happening within their SDLC environment and where do they need to act or sort of fix to improve the efficiency, right? Traditionally, what executives would end up doing is if they need to sort of improve the quality of the software, they want to produce more code, they will end up throwing more developers into the project, which may not necessarily solve the problem because the bottleneck might be in some other stage in itself, right? So those kind of visibility, the executive visibility, this kind of a platform-led approach sort of really enables. Lastly, we are not commercially tied to any cloud provider either. Having said that, our major competition in the market is Microsoft because they go to the market with their Azure DevOps and GitHub story. We've tied up in terms of partnerships, what we call, it's not really a product partnership, but we sort of allow our customers to run. The customer is free to choose whichever cloud he wants. He can, even if he wants to run it on Alibaba Cloud, there's no limitation. So, but our major cloud partners today that we have in our ecosystem are obviously AWS and GCP. With GCP, we have a console level integration where you can actually spin up GitLab runners through the GCP console in itself. I don't have the screen, but I mean, for people interested, I can show it post session or I can show it offline, right? So there is no vendor lock-in there either. So if we are happy with that, that's all I had. For any questions, please feel free to drop that in the chat window, and I'll address those post at the end of the session. Thank you, Michael. Over to you, Bas.
Thank you, Swami.
All right, thank you. I'll share my screen. All right, Swami, thank you. Thank you for showing us how GitLab can help you with delivering your application and helping you in the development process, making it as easy as possible. But taking the next step, delivery to our customers, how do we do that? And for that, I want to show you one of our tools called Multistax. So what is Multistax? Multistax is a turnkey continuous delivery platform that you can use to deploy, run, and secure your applications in any cloud, both public, private, hybrid, whatever you can think of. Multistax is here to help. We have created a platform that you can use to maximize your developer efficiency by making the processes automating as much as the process as possible, and making sure that you can rapidly deploy your applications or rapidly test your applications. It is a self-service based platform. We go one step further by actually automating most of that self-service. So instead of you needing to set up all these different components, getting it to work with each other, Multistax has been designed to take that all away from you and just deliver it as a service. It helps you and as a developer and as an organization accelerate your innovation, because you can test faster, create faster, and move faster with that. And it helps you in your application lifecycle, streamlining both getting application up, maintaining it, creating new versions, or even getting it offline. So with that, I just want to go straight to Multistax itself. This is the Multistax dashboard. Here you can see actually an overview of all your deployments in whatever cloud they are. See an overview of your financial situation in your infrastructure and cloud deployments, and see an overview of your resource consumption. And to actually show how this makes the life of a developer and the operations personnel easier, I want to start with actually deploying an application. For that, we have created a demo application. We've loaded a microservices demo from Google into the platform here. You can just add your repository here with your code and manifests ready to be deployed. With that, we create actually a template. So that means that for example, for organizations that have some sort of multi-tenant environment where the same application is deployed across multiple clouds or for multiple use cases, you can actually template that so you can get fast, quick deployments. And for that, we're going to create one. So we get here the webinar demo application. We'll be deploying the main branch in this case, and we're deploying it to one of our orchestrators. So I'll do that. I'll explain what that is. For more the operational side of things, we have a concept called orchestrators. These are managed clusters, a managed infrastructure that you can deploy on any of the available clouds. In this case, we have AWS, Google Cloud, one of our on-prem clusters, and Azure here. And what we do is we deliver, as they call it in R&D, a batteries included platform. So that means that all the facilities are included. And to show you a bit of what we actually deploy, I have a slide prepared here. As you can see, Multistax here, we deliver a portal and an API. So that means you can both click your things together or hook them in, for example, your CI/CD. As Swami showed, you can like hook into the process in, for example, GitLab, and instead of needing to actually do an action to deploy or do an action to create, for example, a test environment, you can automate it all the way in something like some platform like GitLab and let Multistax do the heavy lifting. Underneath that, we have some FinOps in there, some observability we set up. We can handle your DNS, CDN, load balancer, and ingress. We can do some TLS management for example, certificates and automatically renewing them. And Multistax delivers a fully DevOps platform. We do also some cloud native runtime security. So we proactively scan your applications. We can handle secret management for you, or hook into a platform that, hook into one of the known secret management platforms and do a backup disaster recovery. And we created a cloud abstraction that's non-proprietary. So that means that we use off-the-shelf tools. We set them up for you in advance, and we keep them up with versions. So we can take all that burden away from you. And you as a developer or a platform engineer can focus on the work that's actually important for your application or for your organization, and not be burdened with the run-of-the-mill, done many times things like setting up a platform, getting the services integrated. We all automated it away for you. You can still get in the root. You can couple your own cloud credentials and use your own platform, so you have full insight in what's running there, and you can actually hook into the cluster if needed. So, and also if you have some current clusters, for example, an on-prem cluster, you can just connect that to Multistax, and Multistax can incorporate those workloads and manage them for you, or help you get them even automated in, for example, a platform as GitLab. So to actually look at one of those applications, let's take this one. You can actually see here, this is a really nice overview. So you can actually focus on what's important to you as a developer or platforms operations. You can here see your resources, how they're standing, not only the deployment itself, but also the site services, for example, the AD service or email, or you can actually see specific things within the cluster. And you can take a look at your deployments, the different components of your application. You have a nice overview of the resources it's using and where it's going to. So you can easily see, for example, trends, or check on new deployments, or maybe test features and see how they're reacting to, for example, workload. We have a performance overview where you can see how your application is performing. And we have a built-in vulnerability scanner. This will automatically work for all your deployments, and it will scan them for CVEs and potential problems, and just give you an overview what is there and how you can fix it, with all the links and where you can find it specifically. For example, here in the repo, you can actually see where the CVE is coming from, so you can mitigate them. So to take that a step further, to actually see how Multistax can help you, I have prepared a use case. In this case, it's a multi-tenant product development organization. It's a company that has multiple products with multiple tenants from different environments. So, for example, you have a specific product, but you need to deploy it in multiple environments where they have different requirements, varying platforms, different setups, different providers, maybe also different compliancy and regulations and governance strategies and setups. Multistax can help you here actually get that up and running. So, for example, if we look here, you can have multiple workspaces. You can actually separate your, in this case, tenants within a workspace, and you can give specific persons specific rights to specific workspaces. And from those workspaces, you can actually start to deploy your applications. You can get the orchestrators here, and you can connect them per workspace, and also couple multiple orchestrators, so multiple clouds or multiple environments. So if you, for example, want to separate development from production, or want to separate multiple providers, so you can build in some redundancy, you can just do that with one click of the button. If we look here, we're just trying to offer, we're going to just deploy a simple orchestrators. This is normally what the platform organization would do. They would set up a platform for you. They would set up a cluster with all load balancers and security rules and make sure the authorization is correct. Multistax will just do that for you. So let's set up here within AWS a simple orchestrator. I want new in this case. So what I do here is I set up this case the specific requirements for my platform. So instead of just clicking it together, for example, AWS, or using some sort of Terraform infra as code, I'm just using this form to set this up. This is, of course, all API based. So that means if you want to automate this, if, for example, a tool like ServiceNow, you want to incorporate this in your flow, that's fully possible. We have an API spec, so you can actually test and see how this can be deployed from the API. In this case, I just use the defaults, and I will pick a simple T3 large. So let's create that. And while it is creating, I can also show you that next to just deploying the ready-to-go batteries included Multistax orchestrator, you can actually also incorporate your own infra as code. So you can use Multistax to give you an overview and handle the multi-cloud complex deployments, and you can use your own existing or own customized infra as code to deploy with Multistax. And if we look at one that's already deployed, you can see here it's fully managed. You can actually see here where in this case, the resources are going through, where what different type of services are using financially, and also see what, in this case, the platform, how it's deployed and what the underlying code has done. So as an operations person, you can actually, instead of needing to set this up all manually or research this for every cloud provider, every deployment, you can just on one click of the button deploy this. And from a developer's perspective, you can, by creating those application sources and those application groups, by setting that up, or for example, letting a tool like ServiceNow or GitLab in their pipelines, getting that set up for you with one click on the button, you create a new environment and it's spun up, it's ready to go. And all things like, for example, security and ingress, backups, and all those things are already ready to go for you. Finally, we also want to show you a specific feature of the platform called the self-service. Multistax also includes a tool that can communicate with the platform you're on and actually request resources in with Manifest. So that means that the developers can incorporate Manifest into their repositories and describe to the platform what they want. So they want some sort of storage, they want some sort of bucket, they want some sort of database. Instead of needing to create that or write some Terraform or maybe set up a different pipeline for that, the Multistax battery included cluster can actually set that up for you. So here are some examples. For example, in a simple AWS bucket, you can just specify this in the code from the developer side. And if the platform sees that, it will deploy that in the same account where, for example, the AWS EKS cluster is deployed. And with that, that's my demo for now. We'll let this things deploy and we'll give it over to Swami to take you to the demo from GitLab.
Thank you, Bas. Oops. What happened? Just give me 1 second. Yeah, okay. So I am going to share my screen. So we have a sample application that Bas had deployed here, right? So this is the GitLab UI. And you can see that we have all the files in this main branch, right? Which is also the default branch. And what I'm going to show you today is that shift left approach to security. So typically what happens, as if you will remember what I was mentioning earlier, usually the security aspect generally kicks in after the code has been committed into a branch or repo. It gets picked up later, but it's in this case, what I'm going to show you is demonstrate you is I'm going to create a feature branch and I'm going to show you if I was a developer and if I were to make any changes, then what kind of scanning capabilities I have out of the box and what can I see as part of those SaaS scans, right? A very simple example, right? So this is the main branch. So what I have done here is I've created what I call as a policy. Now, what can this policy do? This policy, if I go and look at the definition, it says anytime a new branch is created, right? It injects a file called GitLab CI YAML into that particular pipeline. So this is a policy that I've created. So every time I create the branch in itself, the pipeline will run. And the pipeline will run a whole bunch of scans. Where do I define those scans? I go to my code and I go and look at my GitLab CI YAML file. If you look at this YAML file, I've added as part of the template, a SaaS scanning template, container scanning, dependency scanning, secret detection, a whole bunch of this. But I can take this scanning because this is very modular. If I decided to spin up another project, and if I want by default as an organization, I want to enforce a certain kind of scan, I would use the policy option, which I just showed you before, right? So one thing is I can go ahead and individually define the scanning per project, but I also can tie an opinionated scan, which by default runs every time I spin up a project, right? So what happens is if I go to my repository again, my policies again, so what I've done is I've tied this particular scan execution, pipeline execution policy, which says that run this, inject into GitLab YAML file this particular scanning template, which is the scanner execution SUE, which is essentially a different project which I have configured as my scanner execution engine. So within this project, I have defined a whole bunch of scans. So this scans will, so I'm pulling the scanning template from a different project and I'm importing that into my project. Every time I spin up a project, this by default will run, right? So I'm going to go back to my original project, which is the demo SUE. As part of this, what I did was I created a branch called main alias, right? So if you go and look at the pipelines here, you would see that all these pipelines have run. There are a bunch of warnings. You can ignore that. But essentially, the pipeline gets kicked in. And if you look at this particular file, let's take an example, right? So the latest scan that was run. It will help you visualize what are the scans that have run as part of the scanning template that I had defined earlier, right? So I've already pre-run it because this takes about 5 minutes and 42 seconds to actually finish in total. But this is something that you can see your pipe. You can see what, so for example, if we take container scanning as an example, I can actually see what is happening in terms of the logs that have gone on, and I can even troubleshoot with the help of AI here, right? And if I say troubleshoot, it helps me find the root cause failure for this. And it also suggests me what do I need to do to actually fix it. So if I really wanted to go ahead and fix it, it says the root cause failure is that a container image specifier scanner could not be found. Obviously, it could not be found because there is no CD environment that's actually attached to this, right? So there is no container image actually in the repo in itself as well. Right? So that is one of the simple AI features. But once the scanning gets completed, what you can actually see is the vulnerability dashboard, right? In this vulnerability dashboard, you can actually filter all the CVEs based on the tool. So in this case, I'm going to just filter it based on, say, GitLab Advanced SAST, right? And I can see that there is one particular severity within this where I can go ahead and click inside and see, which tells me what is the description, what is the criticality of this, and what is the identifiers over here, right? So if I wanted to, again, troubleshoot this as part of my development loops. So all this is happening within the developer branch, by the way. So I've created a feature branch. The moment the feature branch gets created, a pipeline starts running. As part of the pipeline run, I found out these are the vulnerabilities as a developer I have introduced into my code base, right? So if as a developer, if I wanted to fix this as quickly as possible, what I do is explain or resolve with AI. And what it does, again, is go ahead and explains me the feature. Similarly, in the earlier example, it gives me an exploit example of how an attacker can potentially exploit this. It also gives me a fix of what do I need to change within my code base to fix this vulnerability. So this is a very good example of how a developer might go ahead and sort of fix the code and maybe push in a very high quality code back into the parent branch. So once this is fixed, right, I can, as a developer, can determine that I actually need to Either I can confirm this is true, positive, and fix, or I can resolve, or I can say dismiss as accept risk and pass it along the pipeline. Right. So if I go back into my code repo here, right? So what I can do is any changes that I make. So I also want to show you as part of our web IDE features that are available on the platform. So this is natively integrated within the platform as well. So if you can see that these are the, this is my main branch, right? I can actually, as the developer is writing the code, right? Just let's take one example, right? And I want to go ahead and make those, whatever I want to write, I can do my development in this, and I want to use AI for my code development. A very simple example could be code explanations here. So what I can do is I can just select, and I can just say /explain. So as a developer, now I'm using my the AI capability to understand the code, what is done, right? And I can break it down step by step, and I can incorporate the help of AI into my development. So this is another example. What I wanted to show you beyond this was, again, from a policy perspective, if I wanted to as an organization enforce compliance in terms of, say, something like secret detection or any kind of security compliance, I want to enforce it as part of my development, I can do that based on policies as well, right? So if I can go to my secure environment, and I would say policies, and if you look at this, I've incorporated a policy called secret detection policy. So let's have a look at what this policy is all about. Right? So the policy says that run a secret detection scan with the following options. And the condition for that is triggers every time a pipeline runs for all branches. I can select all branches, or I can apply it on a specified branch, and it says with no exceptions. Or I have that kind of granular control that I can define at a group level, right? This is not at a project level, but it is the policy can be applied at a group level and at a project level as well. Okay. So for the purpose of this demo today, what I have done is I'll go back to my repo here. And what I have done is I've created another branch called secret detection. So what I essentially did was, if I go back to my main alias, so I created an alias because I didn't want to change the main. So I'm going to introduce within this EKS YAML file a secret, what do you call it? An introduction of a sensitive variable, right? So this can be done. I did it using an IDE, and as part of it, it created a separate branch, right? So you can see that it was done 1 hour ago. And I introduced on line number 6 AWS key ID, this particular string that you're seeing. So what I can now do as a developer, I've accidentally, say, for example, introduced a secret, a sensitive key, right? So the moment I say create merge request, it is going to again, we can use AI here as well. If I wanted to save time, I don't know what description to fill, I will simply say summarize code changes. And it gives me the description of this change in this code diff involves setting up a VPC with, so it gives me a description of what the file is all about. So, and I'm going to assign this to myself. And the reviewers are also me, right? And I'm going to say delete source branch when the merge request is accepted. That's fine. So I'm going to say create merge request. Rightfully, it should not allow me to push because I have approved pipeline passed with our merge blocked. You can see the merge has been blocked because the secret has been fixed. right? So if I were to go ahead and check resolve locally, see the secret detection. The secret detection has been picked up. And what has it picked up? Let's just see. See, if I say resolve conflict, the secret detection into when I try to merge it into main, it doesn't allow me to merge because this particular key has been picked up. So until and unless I fix this, it is not going to allow me to merge it into main, right? So what I'm going to do is I am just going to say use theirs. And I would say commit to source branch. Now I have fixed the secret that was detected, right? And it's checking if the merge request can be, and now it says it's ready to merge, right? And I'm going to say merge immediately. That's it. The security has been, the code has now been merged. So if you look at my code base, if you look at my repo, you would see, you don't see the secret branch anymore because it is now merged back into main. Inside main, I go back into my EKS YAML file. You can see that line number 6, which would have been if there was no secret detection capability, these secrets would have gone ahead. It could have progressed into the further into the development process. Does that help? I mean, this was a very small demo, but I thought it sort of brings out the more core features of the product really well. The product is really vast. There are a lot of controls available within the platform in terms of we have something called protected branches. If you go to the repo level settings that are available, I have a lot of controls that are available that I can sort of define within the platform. So if this now by default, the default branch is the one that is usually protected. But if I wanted to create a feature branch, I wanted to protect that as well. What does a protected branch do again? It allows me that control of who can merge within that branch and who is allowed to push and merge. All those kind of controls are available the moment you create a branch and you define it as a protected branch. So I can just say select a branch. In this case, I can just say main alias. Require approval of code owners. Code owners is another abstraction where you can enforce file level compliance, file level authorization, who's authorized to change contents of a file. I can do that as well. But in this case, I'm just going to sort of disable it. And I'm going to say who's allowed to merge. I'm going to set it for myself. Who's allowed to push and merge. That's also going to be me. And I'm going to say I'm going to protect this branch. So now you see you have 2 branches that are now protected. So these are broadly the kind of controls and capabilities that are available within the platform. And I hope this was sort of, it gives at least an insight on what the platform can enable for organizations. That's all I had, Bas and Michael.
Yeah, and to take it from there, indeed, you showed like the developer side. I want to show more of the operational side, how you can take this concept and actually use it in production. So I'm going to share my screen. I've switched the deployment I did in the last demo to the main alias. In this case, I did this manually, but of course, you can hook this into the GitLab CI pipeline. For example, on creating a merge request or on creating a branch, you can automatically deploy that as a deployment in one of your orchestrators. And you can actually use Multistax here to, for example, hook into your GitLab CI. You see here it's degraded because, as you showed, Swami, one of the deployments has an error in it. You can actually use Multistax here in your pipeline, for example, by creating a condition where the actual deployment needs to be successful, into making sure that not only the tester run, it's free of security issues, free of bugs, and free of, for example, secrets. It's also deployable. So Multistax API will allow you to read out the deployment status. And you can see here that there are a few servers which are dependent on that service are degraded because it's not working. And you can actually see here you can actually see the degraded state and use that in your GitLab CI pipeline to, for example, roll back or hold your merge request, or for example, if this is the main, the production version, you can actually, for example, use some logic in GitLab to roll back the change automatically. And as described, the orchestrators you can just deploy, and you can run multiple versions of the applications on the same cluster. As you can see here, we have multiple applications running in an orchestrator. So that means you do not have to wait for the whole environment to start up. You can just use one of your orchestrators or preset up one of the orchestrators to actually be deployable for example, branches or merge requests or tags, but to test them and see what's going on. And also, if we can see here, we have a degraded deployment. If we, for example, want to debug this, we can just disable the auto deploy. It means that it's not automatically hold in sync with the code that's in GitLab. We can just manually go fix stuff, test things, maybe change some parameters, or go into the containers in the microservices and actually fiddle around and see if we can fix the problem. And if we have fixed it, we can just merge those changes recreate those changes back in GitLab with their nice web IDE, with the use of AI to get it to help you create the change. And we can once the merge request has changed, we can actually see live here. It's Multistax is checking the code repository in GitLab. We can see our change be live deployed if we auto deploy it again. And for example, if you would just want to do it quick, because this process can, of course, take up to a minute or two for GitLab to get over to Multistax and actually tell it that there is a change, you can fast deploy it with this simple button. And from here for the events, we can also see what's happened in the past hour for this deployment, and we can hear reason about what's going on. If we, for example, see some weird behavior, we can see what's changed here. And when, for example, in this case, you can see here that this application has been degraded 19 minutes ago. It's detected itself as degraded because the microservices did not start up correctly. And that is what I wanted to show you.
So I have one last thing that I wanted to show that I just remembered, if it's okay, is the software bill of materials capability. So every time you get a code, what you can do is actually also look at the dependency list of what the code is actually built like, right? So in this particular, so this is a very useful feature because it comes very handy for organizations that want to enforce compliance. So in this case, it's based on severity, but I can actually filter it based on package manager as well. So you can see the list of packages that are available here. And if I, as an organization, software development organization, want to limit the kind of packages that my development team can use, that can also be configured through the policy, right? So I can create a new policy, and I can define a merge request approval policy where I can define the license scan. So for example, when a license scan is an open targeting all protected merge, and the licenses matches all of the following criteria: status is pre-existing or newly detected, license is matching. I can actually filter out what all the license are the ones that are allowed to be merged into the parent branch. So you have those very, very granular controls in terms of security and in terms of compliance on what kind of code actually gets pushed into your development environment. That's all. I forgot this to show, but yeah, this is something that I wanted to show as well. That's all. We're 3 minutes over time, but thank you for being patient.
Thank you very much, Swami and Bas, for a professional presentation. Fantastic stuff. Thank you. I don't see too many questions in the chat piece. If there are some opportunities for questions and you have the time, please pop them in there. And I think Swami and Bas will be very willing to answer those. So we're looking for any questions there at the moment. I don't see any at the moment. Fair enough. Suffice it to say that obviously we will be sending you the recording, and just to emphasize again the consulting workshop that's available to everybody once you've had some time to peruse the content again, and we will seemingly be in touch with you in the future. And I just want to, again, just wait a minute or two to see if there's any questions or if anybody has anything to ask. Right. Anything more from you, Bas or Swami?
Okay.
Okay, so no questions so far. Everybody's saying thank you. Let's see, great presentation and demo, and it gives us a better view of the platform. So well done, guys. There's no other questions that I have, but I will give it a 30-second wait.
Sure.
Great. Okay. Well, thank you very much, everybody. Have a fantastic day. Look forward to chatting to you soon in the foreseeable future. Thanks, guys. Well done. Thank you so much.
Thank you.